is when you start talking about putting cable in wet locations. Today, we dive into those definitions. What are the requirements for low voltage? And we settle the question, are we exempt from wet location and some other great content? Now, we brought back a fan favorite guest to help us sort this all out. Tim Kuhlman, PE, RCDD, and CDT.
Don't hang up that phone. We've found what you're looking for. Welcome to the Let's Talk Cabling podcast with Chuck Bowser, RCDD. Well, seeing how we're pulling Category 6A, the most powerful twisted pair in the world, you got to ask yourself this one question. Did I pull 295 or 300 feet? Well, do you feel lucky? Do you, punk? In this podcast, you'll learn the differences between a 66 and 110 punch tool, the proper way to install a support cable, along with testing and certifying the cable. What exactly does RCDD stand for? Registered Communications Distribution Designer. Just the expert you need to ensure your cable plant performs exactly as designed. The elite professional, knowledgeable, and experienced in leading-edge ICT design principles. So join us as we talk about the ever-changing world of telecommunications. From ISP to OSP, from copper to fiber, design to installation. Now, send the new guy to the truck for a bucket of dial tone and the cable stretchers, while you listen to an informative program on telecommunications.
So welcome to the show where we tackle the tough questions that are submitted by installers, project managers, estimators, even customers, and sometimes IT personnel. On this show, we connect at the human level so that we can connect the world. If you're watching this show on YouTube or a podcast and you like this content, would you mind hitting that bell button and the subscribe button to be notified when new shows are being published? If you're watching us on a podcast, such as iTunes or Stitchers or some other type of platform, would you mind consider leaving us a rating? Hopefully it's a 5-star rating. If it's not, shoot me an email, tell me what I can do to make it a 5-star rating. These little steps help us take on that nasty algorithm so more people can hear this message and we can educate and enlighten more people in the ICT industry. And also, don't forget, Thursday nights at 6 p.m., we have our Ask Chuck Bowser RCDD, where you get to ask your favorite RCDD your question on estimating, ICT design, project management, career advice. We cover the whole entire gamut. And we're coming back from vacation, so I got some good questions lined up for you. But I can hear you now. But Chuck, what if I can't make it? That's okay. They're recorded and they're put on our website. Make sure you submit your questions ahead of time for preference at questions@letstalkcabling.com. Just again, go to our website at letstalkcabling.com. You will find all of our podcasts and the live streams are recorded and articles that are written from time to time as well. So that way you can always catch up with our stuff even after you don't attend it when we're actually doing it. So let's get back to today's subject. We're talking about wet locations. Now, this is one of those things that as an instructor going around the country and as a project manager and as an installer, I've found that this causes the most confusion because some people, there was even an article written about it in one of the trade magazines. I can't remember if it was Cable Business Magazine or Cable Installation and Maintenance Magazine. It was in one of those. One of those magazines gone, by the way. It talks about how it actually impacts us. So we're going to dive into it today. And like I said, I'm bringing in an expert because you can never have too many friends that are PEs. Welcome to the show, Tim. How you doing?
Doing good, Chuck. It's good to be here again.
Glad to have you back. Some pre-show stuff, we were actually talking about ham radio stuff. So yeah, I'm just starting to get into that and Tim's already kind of into it. So
don't start on radio. Well,
no, we only have 30 minutes. So I definitely had to bring this into you. Now, before we get started, I want to cover some basic terminology that maybe might be confusing, right? So let's talk about the term wet rated, that term that's used by the NEC. What exactly does wet rated mean?
Right. Well, wet rating is what the NEC refers to as what is required for the cabling if you're installing cabling in wet locations. So if you go right to Article 100 definitions and you look to see what is the definition for a wet location, it tells you that it applies to installations underground or in concrete slabs or masonry in direct contact with the earth, in locations subject to saturation with water or other liquids, such as vehicle washing areas, and in unprotected locations exposed to the weather. So they give you a couple of examples of what a wet location is. And then when we see in other sections of the code, it'll tell you that when you're installing cabling in those locations, the cable has to be wet rated or rated to be in a wet environment.
Now, I know the cable jacket has ratings on it, but I don't ever recall it saying wet rated. It's usually
Well,
like
and you
CMP or
won't,
CMR.
right? And there's a deficiency, I think, in the communication and telecom cabling that we have in our industry, is that we don't have that. If you were to look on the power side type wire, you would see something like a THHW, a THWN, those type of designations. That W in the designation that you see on a power cable or wire actually indicate it's wet. For what we do for signaling cabling, data cabling, even optical cabling in the communication circuits, there is no actual designation that goes on the outside that meets the requirements that the code says it has to be wet rated, at least not from a marking standpoint. If it's not marked, then you have to refer to a manufacturer's cut sheet to make sure that the manufacturer has identified that that cable is good for a wet environment.
So the way that you just defined wet locations as a conduit inside of a slab with direct contact with the earth, that could be anything. That could be a sidewalk or parking lot connecting two buildings, or
Yeah.
slab of the building for like the first floor. Now,
Well, absolutely. And that's where it gets us the most. If you have a slab on grade office building and you have a floor box under a conference room table, and you have a conduit in the slab that goes up the wall, that conduit in the slab itself would be considered a conduit in a wet environment.
so in the outside world, we would use outside plant cable, right? Because outside plant cable is specifically designed for wet locations. It's designed for those temperature swings. It's designed for sunlight exposure. A lot of people don't realize that's why the cable's black, is because it's for UV protection, and also potentially rats or vermin, or they love chewing through those cables. So outside plant cable is designed for that. But inside, when you start trying to put outside plant cable inside of a building, don't you run into an issue with the polyethylene jacket?
Well, with any cable you put inside a building, it has to be rated to be inside a building,
Right.
right? And so for optical cables, it would have to be a cable with some type of OFN or OFC, and then whether it's general purpose, riser, or plenum. If it's a copper cable for data and signaling cable, it's we're talking class 2 and class 3 cables. But what we see 99 to 100% of the time, those cables are substituted with CM cables because the code allows you to do that substitution. And so what we see is the cable has to have a CM, CMR, or CMP on it. There is a CMX, but that is limited to unique residential type applications. So we typically don't ever see a CMX for commercial type and industrial type environments. So yes, if it's an outside plant cable, which I would say, what is an OSP designation? We typically don't see a cable that literally says OSP on it either, right? That's also a term we commonly throw around, but what does it actually mean? It doesn't necessarily have a NEC bearing on it, because the NEC doesn't recognize OSP. And for our stuff, we don't have a wet rating. So what we still need, if it's inside the building, it has to have a listing to it: CM, CMP, CMR, OFN, OFNR, something along those lines. Or you're dealing with the situation where you're limited to taking that unlisted cable, say it doesn't have a listing to it, less than 50 feet into a building. And then the next caveat is, even if you were to have an unlisted cable in a floor box under the slab in a conduit, and then it comes up the wall, okay, well, that's part of the, as soon as it comes out of the concrete slab, that's probably EMT. So you're looking at that being the entrance point. You have 50 feet.
Right.
unless you pop it into a plenum space, and then you have an issue, right? Because then that cable is going to be exposed in a plenum, and sorry, you can't do that. So then you would have to actually transition to an indoor rated cable. Well, it's yes and no. We say toxic off gassing, and yes, the way the plastics burn and the materials burn, they do give off toxicity. But most of the UL tests for a cable to be general purpose riser or for plenum doesn't check for toxicity. It looks at burn and smoke. And so if you were to look at, I don't have the numbers in front of me, but something like I think UL 910, UL 166, NFPA 262. Boy, I'm not sure about that one. I have to check that one. If you look at those, you'll see that they really don't check for toxicity. They check for burn and smoke.
Yep. And I only know about the toxicity because I used to be a volunteer firefighter, and most people who die in building fires are from smoke inhalation. And then the number 2 cause of death in a building fire directly relates to the smoke, and that's death by smoke opacity, meaning that you suffered some kind of an injury because there was so much smoke in the building, i.e., you fell down the steps because you couldn't see the steps. Yeah. And that's why we want to limit the amount of smoke in a building. So you were just talking about the cable labels and stuff like CMP, CMR, CMX, all that all those fun ones. So I guess as an installer, right, I guess they'd have to go to the not the owner's manual, but the manufacturer's website to see what the accepted using for that cable is.
You would, and now you would, and get a cut sheet for that cable. And typically what you do see is look for a cable that is, if it's copper, look for outside plant CM or CMR or CMP. Look for those. If you do a search on any of those 2 combination, that means it's probably both suitable for a wet environment, an outdoor environment, and it's suitable to be indoors. Of course, a cable that has all those capabilities is going to be a pretty pricey cable. But I would say before you even look to see what type of cable it is, make sure you understand what type of circuit it is.
Good point. That's why I have a PE on here.
Is because not all circuits require a wet rated cable. And so if you go down the list, Article 770, fiber optic cables, from a code standpoint, there's nothing in there that says that cable has to be wet rated. Now, from a performance, a warranty standpoint, yes, you want to make sure before you put in an expensive fiber optic cable, even if it's to a floor box, that you check with the manufacturer that it's suitable for indoor, outdoor, or for some type of wet environment. The other exception is Article 800. If you're extending, say, a T1 circuit, a D1 DSL circuit, you're extending that into the building and it goes in through an underslab conduit, there is nothing in Article 800 that says that that type of cable that you're extending from the utility, and that's all Article 800 applies to, is that circuit from the utility. If you're extending that into the building, it has nothing in there that says it has to be a wet rated cable. There is a section, Article 847, or it's now 805-47. And if you look at the context of where that paragraph is, that's for cables entering a building. Now that there's a little bit of humor in the code, if you can believe that. Article 800, Chapter 8 stands alone all by itself, right? It's exclusive in that it has to literally reference other articles. Otherwise, those other articles don't apply. The electrical code went out of their way to specifically say that the requirements of Article 310.10c, which deals with wet locations, specifically does not apply. And that's the humor. If it already doesn't apply, why are they going out of their way to say it doesn't apply? But if you look at that paragraph within context, it's talking about underground communication wires and cables entering a building. It's not talking about indoor cabling like what we would typically see for, say, serving up conference rooms. It's when you get to Article 725 that under 725.3L that it talks about corrosive, damp, and wet locations. And truly, if you're looking at horizontal cabling, that's probably 90 to 95% of all our cabling is going to be copper. It's going to be data cabling. It's going to be Article 725. Oh, and by the way, cabling, HDMI cabling, that's also class 2, class 3 type cabling under Article 725. So those HDMI cables, if you run it to an underground floor box, under slab block would also have to be wet rated.
Yeah, that's I'm just clarify this too. We're only talking about the concrete that's in direct contact with the earth. So that's generally going to be the first floor. The concrete
Yes.
for the second floor and the third floor, these rules don't apply. So a lot of people do get confused about that. They think the whole entire thing is wet. I actually did a project once where we had to replace over 600 cables because they were in conduit on the first floor. And after the first winter, they quit working.
Yeah.
Yeah. Yeah. I was actually just
Yeah.
reading an article
And the cable
today.
jacket is somewhat,
Oh,
I
no,
was
go
going to say
ahead.
the jackets are somewhat porous, and they'll actually do wicking. There'll be capillary action where literally, why do I have water in my outlet box 18 inches above the slab? Where'd the water come from? Capillary action can literally draw that water up into the box.
I've never seen that, but that don't sound good to me.
No,
That
it's
sounds
not.
like it's going to cause lots of problems. So really the next question I kind of had was, so if you're putting it, another thing that kind of gets talked about when talking about cables coming in from the outside, this kind of not necessarily wet locations, but you mentioned the 50-foot rule. Isn't there something in the code book that says that you can go past the 50 feet if you use rigid?
Yes, and that's dealing with entrance facilities
Right.
or the point of entrance. And it does say that you can extend the point of entrance using IMC or rigid conduit. But the caveat to that is the code doesn't say anything about putting pull boxes. It says where that conduit or the cable basically enters the wall, the slab, or exits the end of a IMC or rigid conduit is the start of the point of entrance. And I'm paraphrasing, which means if you were to put a pull box there because you need one, and then were to continue on, well, the 50 feet starts where you put the pull box. That could be an interpretation. And so before I put a pull box in, doesn't matter if it's cast, doesn't matter if it's a NEMA 1 pull box, before I put a pull box in and just assume I can extend that point of entrance, I'd want to have a conversation with the AHJ. And I've seen that a lot, by the way. I've routinely see, especially in these data centers where we have bunches of conduits come up and they come up in the wrong location. They come up on the outside of the room instead of the inside of the room. They need to be on that wall and not this wall. They need to separate the controls from the telecom production fiber. And what they really want to do is they want to put a pull box on top of there and distribute out. And so that's a problem if they're going to extend that beyond 50 feet.
Yeah. Now we specifically called out, the conference room scenario, but with single pair Ethernet and all the other technology that's coming in there, we could be putting network drops anywhere, even in industrial facilities. So that obviously can bring up the question: what about a manufacturing plant where they've got some kind of a washdown procedure?
Absolutely. So I see this routinely in the semiconductor manufacturing. They usually have large central utility boiler plants and process utility plants. And so those type of facilities, it's not uncommon for any area that's 8 feet and down to be considered a wet or corrosive environment because it's in a washdown space. We also see that in food manufacturing and in kitchen spaces. So those are typically designed so that they can be washed down and scrubbed. And so those food processing areas, you'll also notice that they have to use different type of conduit connections. So where we can typically use a set screw type connector in an industrial environment, or excuse me, a commercial environment, when you start going to food processing areas, you're starting looking at compression type connectors for EMT type conduits to help keep the water out. And then, yeah, you're looking at if it's in a washdown space where they're going to spray it down, then that's also considered a wet environment.
A lot of people lump wet locations with lightning protection, right? Because the ground's conductive, water's conductive. If even though it's inside the building, is there a requirement by the NEC, or is there not a requirement by the NEC, or is it just good best practice to consider some kind of a protection because it's could be exposed to water and electricity?
Well, they're two completely different sections of the code, and they treat them separately. For one, go back to let's understanding the type of circuit that we're dealing with. There's no protection required for fiber optics unless you have an a metal shield, a conductive shield, in which case, at the point you bring that cable inside the building, you'll want to put some type of bond to the earth ground for the shield. Oh, that's okay. I guess there's a slight delay. If it's a Article 725 cable, it doesn't look at it at all. It says if you have any cabling that goes basically outside, immediately refer to the requirements of Article 800. It doesn't make it an Article 800 cabling. It just means you're going to follow the requirements for Article 800 for protection. And so then you go to Article 800, and then it starts looking at the type of environments that you would likely need protection. And it's not wet locations. It's where you're subject to lightning, if you're subject to over voltage. Say, for example, we run a cable to the outside a picnic area next to a commercial building, outside of the cafeteria. If that is mounted on the outside where it's going to be exposed to lightning, I would put a protector immediately on the inside of that wall where that cable comes in from the camera or from the wireless access point. Put a protector there, right there, and then run it into the rest of them away on my building. If it was, other type of cabling that, say, we went out to a generator, like at a data center, we have a lot of generators out there. That cabling is probably only running out 25, maybe 30 feet outside the building. It may not be exposed to lightning at all because I got the large generator buildings, I got a canopy there, I have the building itself. So I'm not exposed to lightning, but because the generator cables are run underground, I may be potentially exposed to a ground fault if there is a failure in one of the generator cabling. So it's not uncommon in industrial environments for us to still put in protector blocks. When you look at the cost of what a protector block is and what they're meant to do, it's pretty cheap insurance to put that in. So we would still, in those environments where we think there might be a ground potential, put in protector blocks, but it's not because it's wet.
Yeah, you still worry about this cheap insurance because the lightning protection terminal is dirt cheap compared to how much what damage it can do to the generator or what damage it can do to the person inside the building.
Yeah. Right. And the code's there. I mean, the requirements of the code is not there for performance. So there's other reasons we might want to put something there to protect the equipment, but really the protectors are there to protect the building. If you want to protect the equipment, now you're looking at secondary protectors. And so it wasn't uncommon for us to put in something like a keyed switch unit. They would almost routinely call out secondary protection above and beyond the primary protection that you already had for the copper cables coming inside the building.
Right. So I got another question for you. What do I do if I'm feeding a floor box for a slab on grade installation where it's being fed in from the overhead space that's already plenum rated?
So either I need to find a cable that is both plenum and outside plant, and there's a couple out there, or you find a way to do a transition. And so there is I think CommScope makes something what they call their ceiling connector assembly. And it literally allows you to take a cable, and it has basically a little 110 block on each side, and you can come out with a pre-terminated, say, a patch cord with a plug on the end of it, which is really nice if you're going to do one of those type of like a camera design where you're not designing with a jack. You really want to have that plug directly into a camera. Well, it also allows you to use that as a transition point. So if I had the plenum cable coming in overhead, I put a box on top of my conduit stub at the top of the wall. I put that transition in there, and now I transition to my wet rated cable inside that box, and it's EMT conduit all the way down to the floor box.
Yeah, and this whole conversation could be made a lot easier if we're involved in the conversation early in the design process. The CSI has their divisions, right? I don't remember the division numbers anymore because it's been a while since I've dealt with them. But we're typically usually not involved in that conversation because that's usually between the general contractor and the customer, and we're usually brought in after that's already awarded. So we're kind of like usually an afterthought. If we can be brought in during that conversation, we can maybe help design the building to stay away from wet locations, so that way we don't run into these kinds of issues. Have you seen those
Right.
kind of efforts being made, on your side?
Well, geez, for 25 plus years, we've been arguing that you shouldn't be looking at your telecommunication cabling and consulting as tenant improvement. There will always be developers. There will always be those times where the telecom is tenant improvement. But for ground up buildings from the beginning, what you want is all your disciplines there, especially your technology disciplines. It's a very old, what I would call bricks and mortar type thinking, that you don't have your specialty systems, whether it's life safety systems, security, AV, telecom, at least on board from the time you're doing programming, to make sure that you understand the aspects of their systems as you design your building, to make sure that there's space for them. Because face it, what we're doing now isn't the same that we were doing 15 years ago. So we need to evolve. The industry needs to evolve. I can happily say that when it comes to a lot of the large facilities, university campuses, hospitals, uh, manufacturing, data centers, hyperscale data centers, I am seeing where the technology consultant is being brought in at the beginning. We might not have a major role. It might be just our role is just to help them understand the space and where the risers are, and maybe sizing the rooms and helping the architects locate the rooms. But the important thing is that we're there at the beginning of the conversation when the program is coming to place. And really that's just going to save the owner just tons of money if they don't have to try to carve out space later on, or doing what you talked about where they have to pull out cable and put cable, you know, some other cable and more expensive cable code, because they didn't plan for it appropriately.
And that even puts more of an emphasis on customer relations, because if you build that relationship with that customer and you do projects for them over the years, you're more likely to be invited to be part of that process, and your opinion will be even held higher, as opposed to, because we all know that there's cable contractors out there. They'll just literally just they'll find the construction book, right, on bids being done in their area, and go, okay, look, there's 14 buildings going up, and then, well, but you're not really part of that conversation. That's where you're going to really run into problems with that we weren't thought about. The big ones, right? Sizing of the telecom room. That's a huge one, because customers don't like giving up that real estate.
Yeah, I tell you, I would really steer away from projects where the client has issued the technology systems as a performance spec, because 10 times out of 10, I can tell you that the building probably hasn't taken into account the amount of space that we need. And it's growing. The amount of power that we use, the amount of space we need in a riser, well, it corresponds to the amount of technology that people expect in the building. It's the old saying that, guess what? Wireless isn't without wires. Wireless takes a lot of wires, and it has to go somewhere, and nobody wants to see it, and nobody wants to give up program space. So, I have to admit, Chuck, I am blessed to work with clients in a company where, we only take on projects primarily that clients want to involve that technology at the beginning.
Yeah, we're doing more. We're not doing less cable. We're doing more cable. We keep building automation systems, LED lighting. We're just doing more and more stuff, and we need more space, and that just kind of all kind of rolls downhill. And this kind of just kind of crossed my mind. So the wet locations and power over Ethernet, what's the impact there?
It's no different. There isn't any, now from a performance standpoint, maybe you're more likely to see when a cable fails from a performance standpoint, but from a code standpoint, there is anything special. Power over Ethernet is class 2 or class 3 signaling circuit, Article 725. So that doesn't change. You still have the same requirements. So no difference there. Will it act up differently? Will it cause different problems if you do have a cable that starts getting contaminated? Maybe, but there's no special provision.
Yeah, the code book says 90.2 paragraph B, it does not guarantee performance. It says it right in the book. It tells us right point blank. Oh, cool. Any other tips that you might want to share with maybe the potential installers or designers about wet locations? I can
No,
edit out
not
the pause,
really.
don't worry.
Yeah. Yeah, it reminds me of a joke that somebody told me about. A bear goes into a bar and goes up to the bar and asks for the bartender, I'd like a drink. And the bartender says, what would you like? And the bear says, I'll have a whiskey on the rocks. And the bartender says, why the big pause? It says, I was just born with them.
Oh, that's hilarious. That's hilarious. All right. Well, we certainly appreciate your input. And I'm pretty sure we're going to be talking again sometime soon because we got lots of good questions coming in from people. And you seem to be the favorite guest I've had on so far. I mean,
Thanks for saying that, Chuck.
Not a problem.
Maybe not after that last joke.
That's okay. I'll edit the joke out so nobody hears
Okay.
it. Or I won't. Dum, bum, bum. All righty. Until next time, everybody, be safe.
That's it for this episode of today's podcast. We hope you were able to learn something. Make sure to subscribe so you don't miss out on future content. Also, leave a rating so we can help even more people learn about telecommunications. Until next time, be safe.